The first type of discontinuity that we want to look at is a removable discontinuity. You used to call this a hole in the graph, but now you need to formalize your vocabulary and refer to it as a removable discontinuity. So again, let's take a look at our just generic graph here. We'll look at what happens as x approaches c, and we'll talk about the function value L. You have a removable discontinuity when the following criteria are met. The limit as x approaches c of f of x exists, and in this case we'll say that it's equal to L. So the limit exists, and I can draw this limit behavior right here. We've looked at various limit statements where if I gave you this graph, you would say that the limit as x approaches c of f of x is equal to L. It exists right there. But what happens here is the reason why we have a discontinuity is that the limit as x approaches c of f of x does not actually equal f of c, meaning either the function is undefined at c or it's defined at some other place besides L. So I might have a point that's lower right there. That function is not continuous. It's a removable discontinuity because the limit exists, but the limit is not equal to the function value. And we should make a special note here that f of c does not have to be defined. Does not have to be defined for a removable discontinuity to exist. So I didn't even have to establish this point here at c. If I could have just left and said f of c was undefined, I still would have had this criteria that was met. I still would have had a removable discontinuity in my graph. And we've looked at things like this so far in this class. Let's just take a look at the function. F of x is equal to x squared minus 16 divided by x minus 4. Well, we know right off the bat here with this function that f of 4 is undefined. So we already know that the function value is undefined. We're going to have some kind of discontinuity there. We can verify that it's a removable discontinuity if we take a look at the limit as x approaches 4 of this function, x squared minus 16 over x minus 4. And as you've seen so far in this course, I can factor the numerator and say the limit as x approaches 4 of x plus 4 times x minus 4 over x minus 4. Dividing out my common factor, I get the limit as x approaches 4 of x plus 4, which is 4 plus 4, which is 8. So the limit as x approaches 4 exists for this particular function. However, this value is not equal to f of 4, and so therefore we can say therefore f of x, this function right here, has a removable discontinuity at x equals 4. The limit existed at x equals 4, but that was not equal to the function value. That is the criteria that give us this type of removable discontinuity.